Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. We are talking about the numerical representation of the natural language data. So let us now continue to understand what are the different kind of techniques that we can utilize to transform our unstructured data into numerical representation. So let us now talk about vector space models. So these are mathematical model that represents text as unit vectors. Okay, so if we can transform our unstructured data into different kinds of vectors, then what we can do is we can utilize the cosine similarity. Can find the similarity between two different text. And how can we find the similarity between these two different text? Because we have already converted these two different text into their vector form, right? So cosine similarity is nothing but the cosine of the angle between their vectors. So similarity we can write as, let's say there are two vectors a and b. So a vector cross dot b vector. So this is the formula for finding the similarity between these two vectors, right? We can also use Euclidean distance to capture the similarity. Now a good technique of vectorization differs from a bad text representation only in how well we can create the vector representation of the textual data. So everything that your model means, whatever the quality of the model is totally dependent on how well you can transform your data into its vector form. So if you are doing a great job at transforming at this step, then what happens is your model is capable of developing better outputs for your natural language data, right? So now we have already talked about one of the technique, that is one hot encoding, while we were talking about creating the numerical representation for the categorical data, right? So one hot encoding is a very useful technique. Now let us look at how we can utilize that one hot encoding to develop our vector representations. Okay, so one hot encoding. So, let us write 4 sentences, 4 very basic sentences to get a worked out example for better understanding the numerical representation from the textual data, right. So, the first sentence is, let us say, birds sing loudly. Okay. Second sentence is, the sun rises. Third is, rabbits eat carrot. And fourth sentence is, the moon glows. So, these are 4 sentences that we will utilize moving forward to understand how we can transform our data into numerical representation. So, utilizing these 4 sentences, we can write our full vocabulary. That this full vocabulary will contain the distinct and unique words from these 4 sentences. So, this could be, the first word could be birds, then sing loudly, then the next word could be the sun rises, rabbits eat carrot, moon and close. Now, you may point out that why I have not written this, because we are talking about the distinct words. So, this is also present here in the second sentence. So, we are only writing the distinct words that are available in these 4 sentences. So, this is a complete vocabulary of these 4 sentences, which we need to transform from textual data to your numerical representation, right. Now, we have all these words and we have the indexes. So, the second step is to create an index. So, there are 11 unique words and we have started our index from 0 until 10. Okay. So, each word will have an 11 dimensional 11D vector. How? So, if you want to create the numerical representation of the first sentence, so what you will do is, you will take birds and you will find at which index it is. So, birds it as 0 index, right. So, you will, what you will write is, you will code as 1 for this first word. Okay. Then the second word is sing loudly. So, these also are 1, but for the rest of the words there are nothing in this sentence, right. So, we will use zeros. So, now this single vector will contain 11 values and each value will represent what is the actual position where a word is represented in your index. Okay. So, this is how your 11D vector will be utilized to represent these words, right. Now, you can say that one hot encoding OHE is highly intuitive to understand. And you can also point out that the size of the one hot encoding is equal to the size of the vocabulary. right? But there are still challenges with this technique. So, what are these challenges? The first is the large vocabulary challenge. When your vocabulary, when vocab is large, then the vector representation will be mostly sparse. That means it is not filled. So, sparse data is highly problematic for our machine learning models. So, that is why the one hot encoding is not utilized as much, even though it is highly intuitive. Okay. The second challenge is out of vocabulary problem, also known as OOVP problem. So, to understand this, let us say we have these 4 sentences and the 5th sentence includes some word that is not yet seen in this vocabulary. Okay. So, what happens is you do not have an index for that word. So, to create a model that can utilize the next sentence, you have to retrain your complete model, right. So, this is where your retraining cost and your complete model building cost will increase every time you get a new kind of sentence. Okay. So, this is why we do not generally utilize one hot encoding while creating our models when the vocabulary is very large, as these models are not so intelligent as we want them to be. Okay. So, now let us come back to the next kind of representation technique, which is known as the term frequency and inverse document frequency, also known as TF-IDF, right. So, the basic fundamental concept behind this technique is that some words are more important in the document than other words. So, you can relate to this statement, like whatever we are doing in one hot encoding, every word had the same kind of importance, right. But usually it is not the case. In real world, some of the words in a particular sentence holds much more value than other words. So, unlike other techniques, TF-IDF quantifies this importance Now, let us understand this with a short example that let us say we have, let us take 10 documents with different content. So, what can happen is one word from the first document can hold high importance, but it may not hold the same importance in rest of the documents. So the importance should be given to this word only in the first document instead of assigning the importance in whole corpus. So there are two different things that are included in this technique. The first is term frequency. Now whatever we have explained here, we need to replicate this into our numerical techniques, right? So the first is term frequency. So this can be represented as TF, and it is the ratio of number of occurrences of a term T in document D divided by the total number of terms in document D. Okay. Now what is inverse document frequency? So IDF can be represented for each term T as the log of total number of documents, total number of documents in the corpus divided by documents, number of documents with term T. Okay. Finally, if you have calculated these two numbers, then the final TF-IDF is simply the multiplication of these two numbers, TF into IDF. Okay. So now let us come back again to our example of those 4 sentences. Okay. So our text is, first is birds sing loudly. Second is the sun rises. Third is rabbits eat carrot. Fourth is the moon glows. So now we will demonstrate the complete TF-IDF calculation for these 4 sentences, and consider these 4 sentences as 4 different documents with a large number of textual data. So here, to ease out our explanation, we are utilizing very simple sentences. So step 1 is list the items in vocabulary. That we have already done, and we know there are 11 items, right? Step 2 is to calculate term frequency. So here what we know is all sentences have 3 words. So the first sentence is bird sing loudly, so there are 3 words. Similarly, all these sentences have 3 words. So your term frequency formula, which we have written here, is that number of occurrences of a term in a document divided by the total number of terms in the document. So these are 4 different documents, right? So the first document has 3 terms, and what is the term frequency for the first word? This is 1. So birds only occurred once in all your documents, right? So this is 1 by 3, which calculates to 0.33. So most of the words have the same term frequency here, but except two instances of the word, right? So this will have difference. Third step is calculate IDF. Now IDF is the log of n by document frequency. Okay, so this we will utilize for each word, and we will calculate the IDF in our next table. And finally, the fourth step is to calculate the TF-IDF. Okay, so we have already shown you how to calculate the term frequency. So we can easily write here that the birds, this word occurs only once, so it was 1 by 3, so it is 0.33. Again, sing is occurring only once, this is 0.33. Now this is 0.33. So why this D is 0.33? Why it is only 1 by 3? Because we are finding the number of occurrence of the word in this document. So this is document 1, this is document 2, this is document 3, and this is document 4. So in document 2, the occurrence of D is only once, right? So that is why it is 0.33 here. Now your document frequency, here we will calculate what is the number of times a particular word occurs in all your documents. Okay, so birds occur only once, this is 1, 1, but the occurs twice, so it will be 2, then 1, 1. Okay, finally we will calculate the IDF value. And how do we calculate this? We will take the total number of documents in the corpus, which is 4, and the number of docs with the term T, whatever term T which we are calculating the IDF, we will utilize this. Okay, so let's say for this birds, the IDF will be IDF for birds is log of, we have 4 documents, so total number of documents divided by the document frequency. So this occur only once, so this is 1. So log of 4 will be around 0.60. Okay, so most of the words occur once, and their total number of documents is also 4. So we can easily write for this also as 0.60, 0.60. But the word occurs twice, so IDF for the is log of 4 divided by 2. Okay, so this will be log of 2, which is somewhere around 0.30. This is 0.30, then this is again 0.60, 0.60. This is again 0.30, and finally we will calculate the TF-IDF. Okay, so multiplying these two things, we will get somewhere around 0.2. So, and this will be different. So, this is somewhere around 0.1. Okay. So, this is how we can calculate the TF-IDF values for each of the word in your corpus. Now, after calculating this TF-IDF, what you have received is you have completely transformed your words from your corpus into a numerical representation, right? And you can utilize this numerical representation to develop your natural language processing models. Okay. So, now let us come to a new application of the natural language processing, that is text classification. So, this is also referred as topic classification or text categorization or document categorization. Right. But this is not similar to another terminology in natural language processing, which is topic modeling. So, topic modeling is a completely different thing where we do some other classification things, but text classification is different. So, text classification assigns one or more categories to a given piece of text from a larger set of possible categories. So, this is similar to what you are doing in image classification or speech classification, where like let us say in the example of image classification, what you are trying to do is to identify different kinds of objects in an image like cat or dog, right. So, there were only two classes, either the image will contain a cat or a dog. But here in natural language processing, what you can do is you can identify the sentiment of the text, like is the is whatever the text is saying, is it positive or negative or ambiguous or something like that. So, here the categories can be very multiple or very different from what you can utilize, right. So, the categories can be binary or multi-class or multi-label. So, we have briefly touched about what is the difference between these three things, right. So, binary is containing two classes. In multi-class problems, we have more than two classes, but only one of the class is the output of the classification system. The third is the multi-label. Here this allows multiple assignment of categories to a single instance of text. Okay. So, an example of this could be your news articles. So, a particular article could be labeled as a sports article, or the name of the sport like tennis. So, the news article agency is trying, what news article agencies is trying to do is they are trying to label their articles in with multi labels, so that if a user wants to, let's say, distinguish between different kinds of articles, so they can filter out directly with these kind of labels. Like if they filter all the articles that contains the labels with sports and tennis, then what they will get is only those articles that contains the news about tennis, right? So, the applications of this text classification is very wide, and we in our daily lives we also utilize these text classification algorithms and their outputs. One of this is the content classification. And where do we utilize this? We utilize this in our Gmail or any other email platforms. So, Gmail provides you with 4 different categories like primary, social, promotions, updates. So, these categories are self assigned by the system. Nobody else, no manual assignment is being conducted by the Google organization, right? Similarly, customer reviews on the e-commerce websites. So, how do we utilize these large data set of customer reviews from the e-commerce websites like Amazon? Okay. So, what we can do is we can understand the perception of the product by customers. So, let us say if you understand how your particular product is being seen by the customers, then you can tweak your product design, your product manufacturing or something like that, so that you can get more sales. And since these all customer reviews are kind of a large data set, so you cannot utilize all of these data set by manually trying to tag them. So, you need intelligent machines to develop some algorithms, and so that they can automatically do these tasks. So, now let us stop today here, and we will continue in the next lecture. Thank you.